Students, today we are going to continue with the lesson that we had started in the last session. That lesson is gravitation. And what are we going to study today? Today we are going to study how Newton gauged inverse square law, the law which we studied, which states that gravitational force is directly proportional to product of their masses and inversely proportional to square of the distance between them. So whichever forces which are inversely proportional to the square of the distance, that is called as inverse square law. This inverse square law are applicable at many places and in gravitation is also applicable. Our topic of discussion will be how Newton gauged this inverse square law. Then we will also study importance of gravitation law, and we are also going to study free fall. Okay, so these are 3 topics that we are going to study today. And this is part number 2 of the lesson. Do you remember what we studied in the last session? In the last session, we had studied introductory section of the chapter, and we had also studied about gravitation along with its derivation. So to start with, we are going to ask ourselves, how did Newton gauge inverse square law? So there has always been a great interest in the motion of planets. It was not only Newton who had this curiosity, but the scientists and observers before him also. They had a keen interest in this motion of the planets. By 16th century, lot of data on motion of planets had been collected by many astronomers. And based on this data, Johannes Kepler derived 3 laws which governs the motion of planets. Johannes Kepler was an astronomer, and this data was in fact created or produced by his teacher and guide Tycho Brahe. This Tycho Brahe had collected data based on his observations. So he was astronomer himself, and Johannes Kepler at that time he used to work with Tycho Brahe. And after his death, after Tycho Brahe's death, Johannes Kepler collected this data and he tried to analyze this data. So based on this data, Johannes Kepler derived 3 laws which govern the motion of planets. These laws proposed by Johannes Kepler are called as Kepler's laws. Let us see the 3 laws one by one. What is first law? The first law states that the orbit of the planet is an ellipse with sun at one of the foci. So the orbit of the planet is not circular, it is an ellipse with sun at one of the foci. This was the first law stated by Kepler. Second law was the line joining the planet and sun sweeps equal area in equal interval of time. And the third law is cube of the mean distance of planet from sun is proportional to square of its orbital period. So these are the 3 laws stated by Kepler. So to put it mathematically, r cube upon t square is equal to constant. So this is a mathematical statement or mathematical form of third law. Now let us look at this law one by one. Let us see first law. The orbit of the planet is an ellipse with sun at one of the foci. So if planet is revolving in this orbit, then sun is at one of the foci. Suppose it is at O. Students, remember that in the age of satellites, where we have sent innumerable number of satellites for space exploration, it is very easy to say that yes, planets revolve in elliptical orbit. But in the period I am talking about, which belongs to 17th century, at that point of time we didn't had any satellites. With the very basic instruments, with the basic observations of the planets for a long period of time, after this observation we had deduced this law. So the greatness of these scientists is that using very minimalistic devices, but with lot of hard work over a period of time, they had come forward with these laws. And Tycho Brahe means teacher of Johannes Kepler. He had spent his entire life in only these observations. Okay, and after these observations, Kepler was able to propose this law. So it is not a matter of time or a matter of one life. Okay, there are numerous astronomers and there are numerous lives which has gone in proposing these laws. Well, this is the first law. Orbit of planet is an ellipse with sun at one of the foci. Then second law, the line joining the planet of the sun sweeps equal interval in equal area in equal interval of time. So if OA, this axis, when it moves towards OB, it sweeps some area. Now suppose this area is covered in one day, for example. Okay, now if the planet moves until C in the another day with the same time, of course, then OBC, the area of this sector will also be same. So if you calculate areas in some specific interval of time, so for example, if you calculate the area of sectors after each day, okay, you will find that this area is same. So the statement reads, the line joining the planet and the sun sweeps equal area in equal interval of time. Then comes third statement, the cube of mean distance of the planet around sun is proportional to square of the orbital period. So r cube means the distance, mean distance, its cube, r cube, is proportional to square of the period. So r cube upon t square will be obviously constant. So these are the three laws stated by Kepler. Let us solve a numerical. The question reads, the mass of the earth is 6 into 10 raised to 24 kg and that of the moon is 7.4 into 10 raised to 22 kg. Now, if the distance between earth and moon is 3.84 into 10 raised to 5 kilometers, calculate the force exerted by the earth on the moon. Here, G, universal gravitational constant, is same, 6.7 into 10 raised to minus 11 Newton meter square per kg square. All the information that we need to calculate gravitational force has been given. So mass of the earth is 6 into 10 raised to 24 kg. Then mass of the moon is 7.4 into 10 raised to 22 kg. Then distance between earth and moon is already given, which is 3.84 into 10 raised to 5 kilometers. Well, this 3.84 into 10 raised to 5 kilometers has to be converted to meters, and to convert it into meters we will multiply it with 1000. So that will give me 3.84 into 10 raised to 8 meters. Now G we already know, 6.7 into 10 raised to minus 11 Newton meter square per kg square. Now the thing is simple. What we have to do is use this gravitational force equation, which is F is equal to G m into m divided by d square. So you have to simply substitute the values. You have to simply plug in the values that are already given. So capital G is given 6.7 into 10 raised to minus 11. Then capital M 6 into 10 raised to 24. Then small m, that is mass of the moon, which is 7.4 into 10 raised to 22 kg, divided by distance square, which is 3.84 into 10 raised to 8 meter and its square. Now, if you calculate this using logbook, if you have it, then you will find that it comes out to be 2.02 into 10 raised to 20 newtons. So that is the force exerted by Earth on Moon. What is that? 2.02 into 10 raised to 20 newtons. Now let us see importance of Newton's law of gravitation. What is the importance? The universal law of gravitation successfully explained several phenomena which were believed to be unconnected, which were not known that these two different phenomena are connected to each other. The first thing is the force that binds us to the earth, they are same. The motion of moon around the earth, that the reason is also same. The motion of the planets around sun, the reason is same. And the tides due to moon and the sun, high tide and low tide that we observe in sea, that is also because of this gravitation. So these various phenomena occur because of one single reason, and that is gravitation. Now comes the last topic, which is free fall. We have learned that earth attracts object towards it. We all know this. When we throw an object in the air, it's bound to fall down like this. This is due to gravitational force. Whenever objects fall towards earth under this force alone, we say that objects are in free fall. I repeat, whenever objects fall towards earth under this force alone, we say that objects are in free fall. Let us move on to the next point. While falling, there is no change in the direction of motion of the object. Direction doesn't change when object is falling down, but the velocity, the magnitude of the velocity is going to change. Any change in velocity involves acceleration, that we all know. Okay, if velocity is changing, then acceleration will also change. Whenever an object falls towards the earth, an acceleration is involved. This acceleration due to Earth's gravitational force, this acceleration is called acceleration due to gravitational force of the Earth. It is also called as acceleration due to gravity. It is denoted by a symbol small g. Don't confuse between capital G and small g. Capital G is universal gravitation constant, whereas small g is acceleration due to gravity. And the unit of small g is meter per second square because it is acceleration. And with that, we come on to the last part, which is assignment. So the first question is state Kepler's law. Second is a problem. The mass of Jupiter is 2 into 10 raised to 27 kg, and that of Europa, which is moon of Jupiter, is 4.8 into 10 raised to 22 kg. If the distance between Jupiter and Europa is 6.7 into 10 raised to 5 kilometers, calculate the force exerted by Jupiter on Europa. The value of capital G is same, 6.7 into 10 raised to minus 11 Newton meter square per kg square. What you have to find? You have to find force or gravitational force exerted by Jupiter on Europa. Then third question is state importance of Newton's law of gravitation. And the last but not the least, what is free fall? So this is today's assignment. Well, that was all for today. Thanks for attending this session. If you have any doubt, feel free to ask. See you in next session. Until then, take care. Bye bye.